So the aim of this final section is all about drawing conclusions about the mean of a normal distribution using data collected from a real life situation. So we're basically doing a hypothesis test with the mean of a normal distribution. So let's look at this specific example then. So we've got a company and the amount of juice in a carton dispensed by this machine is normally distributed, and we know that the standard deviation is 3 millilitres, but we're not told what the mean is. Well, the company claims that the mean amount of juice per carton is 60. So the company claims that the machine is set up so that the mean is 60. And the trading inspector obviously thinks that the company is lying, and he thinks that they're overstating the amount of juice per carton. And he investigates this and he collects some data about 16 cartons. He measures the amount of juice in them, and he finds that the mean amount of juice in those 16 cartons is only 59.1. So at first glance, it looks like the inspector has evidence to say that the company is overstating the amount. So let's set up the hypothesis test then. So the first thing that we need to do is we need to always define a random variable. So we're going to define x to be the amount of juice in a random carton. Now we're told that x is normally distributed, because it says it here in the question. And we don't know what the mean is, so let's leave that for now. And we know that the standard deviation is 3. So here I need to put 3 squared because this parameter needs to be the variance. And we don't know what the mean is, the true mean, so let's leave that as mu. So here mu is going to be the true mean of x. So the true mean of the volume of juice in a random carton. Well, because we're doing a hypothesis test, we need to define our null hypothesis and our alternative hypothesis. So the null hypothesis would be that the amount of juice in the carton is 60 millilitres, i.e. on average, so i.e. the company isn't lying. And the alternative hypothesis is that the true mean, well, the inspector thinks that the company is overstating the mean. So the inspector thinks that the company is saying that the true mean is higher than it actually is. So the inspector thinks that the true mean is actually less than 60. So you're getting less in your carton than you're paying for. Well, the data that we've got to try and support this is the inspector's taken a sample of 16. So we've got a sample of 16 cartons. And you don't need to write this down, but I like to actually say what the sample is. We've got x1, x2, up to x16. So x1 would be the amount of juice in the first carton, second carton, all the way up to the 16th carton. And what the inspector is doing is he's taking the sample mean, which is x bar. So he's adding up all of these cartons that he's collected and working out what's the mean amount of juice in the carton. And at this point, it's worth writing down what does x bar have to be in order to try and support H1. So in order to try and support the inspector's claim, he wants x bar to be less than 60. So small values of x bar support the alternative hypothesis that the inspector is correct with his hypothesis. And notice that the smaller x bar is, the more confident you can be that the company is lying. For example, if I collected 16 cartons as an extreme case, the average of those 16 cartons was 10 millilitres, then I'm almost going to be certain that the company is lying. So the smaller x bar is, the more confident I can be that H1 is true, and we can reject H0. So what we do with these hypothesis tests is we're going to assume that H0 is true. So let's assume that the company is not lying. Now, if H0 is true, then x bar is going to have this distribution. It's going to be a normal distribution. The mean is going to be 60 if the company is not lying. And the variance is going to be the variance of x divided by the sample size, which is 16. So here I've used the formula. X bar follows a normal distribution with mean mu and variance sigma squared over n. So in this question, mu is 60 because that's what's true if h naught's true, and sigma squared is 3 squared because the standard deviation was 3. So what we've got to do is we've got to somehow decide whether the value of x bar that we saw, so 59.1, is small enough to say that the company is lying or not. So we're going to look at two different ways of doing this. And if you don't know these two different ways, then I would recommend you look at the Year 1 Statistics playlist, and it's the final chapter, which is hypothesis testing with the binomial distribution. So the first method that we're going to look at is the critical value method. And what we're going to do with the critical value method is we're going to draw a little sketch of the distribution of x bar. So we've got x bar along the horizontal axis, and we're going to draw out this distribution if h naught's true. So assuming that the company isn't lying. So we should probably put that under h naught. This is what the distribution looks like. So we know that under h naught, if the company isn't lying, then x bar will be centered around 60, and it's going to have a variance of 3 squared over 16. Well, we know that the significance level is 5%. So because small values of x bar support h1, this basically tells us that in order to reject h naught, we need to be in the left tail to reject h naught. And by the left tail, we mean we need to be in the left 5% tail to reject h naught. That's what the significant level tells us. So by being in the left tail, we mean x bar needs to be small enough to make sure that we're in the final 5% region of our distribution of x bar. Sorry, this should say x bar on the horizontal axis. So let's say our critical value is c. So we basically want the probability of x bar being less than c is equal to 5%. So we know how to do this. We can use our calculators using the inverse normal function. So we go to our calculator and we go on stat mode, distribution, normal, inverse normal. Now the value that we want to try and find is c, and we know the total probability to the left of c is 5%. So we're going to do left tail. The area to the left of our unknown value is 5%, so 0.05. Sigma is the standard deviation. So we've got to be really careful here. This here is the variance of x bar. So the standard deviation of x bar, which is what our calculator wants, is going to be the square root of this thing here. So it's going to be the square root of 3 squared over 16. And if we do that, we square root the top and get 3, square root the bottom and get 4. It's really important that you put the square root of the variance into your calculator. So we're going to put 3 over 4, 0.75 as our standard deviation, and if h naught's true, the mean of x bar is 60. So don't get confused with the standard deviation here. Here we're sketching the distribution of x bar because that's the data that we've got to test this. We're not bothered about this distribution of x here. So we're using this variance. So if we work that out, we get 58.77. So C is 58.77. So that means that if x bar is to the left of 58.77, smaller than that, that means we're in the final 5% and we can reject h naught. So let's have a look at our value of X bar that we got. We got X bar as 59.1. So 59.1, our value, is to the right of our critical value. So that means we're not in the final 5%, not in the left 5%. And we're going to explain why that is. It's because our value of X bar, 59.1, is greater than this value here, which means we're basically to the right of 58.77. So do not reject H0. And then notice that I've said do not reject H0 rather than accept H0. You might get away with it saying accept H0, but strictly speaking, we're not going to say that the true mean must be 60, because I could repeat this whole experiment with mu being H0 being mu is 60.1, and I would have got exactly the same result. So I can't do two separate hypothesis tests and conclude two different values of mu are true. All I've got evidence to say is there's not enough evidence to suggest that the company is overstating the amount. So do not reject H0. There is insufficient evidence to suggest that the company is overstating the mean amount in a carton. And here, notice that I've done it in context. You'll lose marks if you just say there's insufficient evidence to suggest that mu is less than 60. You've got to do it in context. And I'm using this word insufficient evidence because I'm just from my 16 sample, I can't reject H0. But if I had, perhaps if I collected more evidence, or if I sampled 50 cartons, then perhaps I would have been in the critical region. So I'm just saying there's not enough evidence to get me into this critical region.